This animation illustrates the Lorentz attractor. The Lorentz is an example of a coupled dynamic system consisting of three differential equations where each component depends on the state and dynamics of the other two components. You can think of each component, for example, as being species, foxes, rabbits, grasses, and each one changes depending on the state of the other two. So these components, shown here as the axes, are actually the state variables or the Cartesian coordinates that form the state space. Notice that when the system is in one lobe, x and z are positively correlated, and when the system is in the other lobe, x and z are negatively correlated, the other wing of the butterfly. We can view a time series thus as a projection from that manifold onto a coordinate axis of the state space. Here we see the projection onto axis x and the resulting time series recording displacements of x. This can be repeated on the other coordinate axes to generate other simultaneous time series. And so these time series are really just projections of the manifold dynamics onto coordinate axes. Conversely, we can recreate the manifold by projecting the individual time series back into the state space to create the flow. And in this panel, we can see the three time series, x, y, and z, each of which is really a projection of the motion on that manifold, and what we're doing is the opposite here. We are taking the time series and projecting them back into the original three-dimensional state space to recreate the manifold, the butterfly attractor.